Good morning, colleagues. Good morning, Professor Tyler. My name is Enrique Alan Guerrero, and this is my project presentation. The project consists in the automation of a chocolate line. This chocolate line produces chocolate sprinkles and chocolate chunks. First of all, sorry for not being able to be there with you for that presentation, but I will do my best so we can enjoy this presentation. Also, maybe my English is not the best one because I'm from Mexico, but I will try to make it as clear as possible. So let's go on. As we said before, in this line we produce chocolate sprinkles and chocolate chunks. First, I would like you to show you what are them. These are the chocolate sprinkles and these are the chocolate chunks. The chocolate sprinkles are mainly produced for a customer here in Mexico. It has a very famous pastry here in Mexico called Gansito. And also the chunks are from another bakery industry that has cookies with chunks. Well, first I would like you to show you how was the line before the automation done. It consisted first of the mixing stage, then it has four consequent stages, which were the feed of ingredients. Then it goes through a extruder. From the extruder we got like a chocolate nozzle, which goes through a cooling tunnel. And at the end of this cooling tunnel we have a mechanical cutter, like a guillotine. And then the small pieces of chocolate were taken into the shining process. Here, as you can see, the mixing stage was very manually done. Here the worker put all the ingredients and the mixer was turned on and the mass was produced. Then in the manual fit of ingredients stage, all the other ingredients were put here manually. Here the product quality has significant variations due to the lack of automatic handling of ingredients. Also, the lack of devices for process control such as weight, time, temperature, order of fabrication, and some others. It has a very high dependence on the operator's decisions, so it doesn't give you a good quality of the product because it can vary a lot depending on the operator working. Then, in the extrusion entrance to the culling, the production line has a capacity of 400 kilograms per hour and a very low efficiency, less than 40%, because the culling tunnel doesn't have sufficient capacity for the two extruders that were installed at the line. As you can see, here we just have one because there were another one here, but it's already dismantled. This photo is from not when the line was operating, this was obsolete. There was something here, but it has been taken, but here you have an idea of how was it. So there was it could only work one extruder at the time, and also the band of the cooling tunnel had considerable damage, and its useful area was greatly reduced, and this also contributed to the low efficiency mentioned. Well, we have here the facts. We have a production line that had a capacity of 400 kilograms per hour. As I said, a very low efficiency, less than 40%, because as we said before, we can only use one extruder at a time when we have two. And also the cooling tunnel band was very damaged and the useful area was greatly reduced. So from this we make a conclusion and we see some opportunities. We could say that the line in general at all stages of the process, from mixing the ingredients to discharging the cooling tunnel, had high potential risk conditions for food safety. Due to the manipulation of materials by the operator, no control, the lack of control devices for foreign materials, equipment with high risk of generating metals by friction within metals. Like I said before, at the end we had a guillotine, which was metal, and the band was metallic, so there was, even though at the end there was a metal detector, sometimes it doesn't detect everything. So from these opportunities, we create a new project, a project to automate this line. The objective of this project was to increase the efficiency of the production line to create chocolate sprinkles and chocolate chunks, as well as an improvement in the food safety condition and the quality of the finished product by automating the operations and replacement of equipment with high food and physical safety risk. So we propose a solution, and the project scope for the solutions includes the design and installation of an automated production line from loading the ingredients to destroying the cooling tone, everything automatic. This will have a capacity of 1,000 kilograms per hour with an expected efficiency of 85%. Here is a general design of the proposed automated line. First, the process starts here at the top of this mezzanine. Here we have different containers with the ingredients. Here is one, here's another, and behind this mixture there's another one with another ingredient. Each of these containers have load cells which deposit the exact amount of material needed to the mixer depending on the recipe. Everything is done automatically, and here in the mixer the mass is produced. It goes down to the extruder. The extruder gives out like chocolate noodles, we can say that, the chocolate noodles, and this is a straight line here, and it goes through this rotating breaker to break the noodles into small pieces, like in sprinkle sizes, and then it goes through the cooling tunnel out to the end. It goes to this elevator. It goes to this sieve to separate the big sizes from the small sizes, because there are some sizes that we don't want, and we can reuse them and put them in the next batch in the mixture. And there's a dosing machine to put it in boxers or a sack or whatever we want. Here is a more detailed design. As I said before, here are the different containers with each sieve, everyone, or different detector with load cells. For example, here are the sugar container, here the cocoa container, here we have another one. It could be fat, or it can be an emulsifier, or this one also a reprocess from the previous batch. It goes to this to the mixer. Here the weighing of all powder and liquid ingredients are done automatically through load cells mounted on the mixer. Everything is controlled by a PLC in which the recipe for different products are set. The recipe controls the amount of each ingredient, the order in which added to the mixture, also the mixing times in each stage, and the temperatures of the process equipment. With this we can ensure our quality. Then after the mixture, as I said before, it goes through this compressor and then go to the extruder. It goes all the way down. It creates like this that we call the chocolate noodles. It goes to this rotating breaker, and then it goes to the cooling tunnel all the way to the end. And as I said before, it goes to the elevator. There's like this vibrating machine that is like a sieve. It goes here we have a metal detector, and there is the dosifier machine. As we saw on the course, there's different kind of automation. This one is I think is a fixed automation, because it is included in all the features of fixed automation that are high initial investment for custom engineered equipment, high production rates, relatively flexible in accommodating variety. Actually, we just have chocolate sprinkles and sometimes chocolate chunks. Also, the strategy for automation improvement that we saw on the course, the three that applied for this project are the improved material handling and storage, process control, and optimization, plant operations control. Okay. Also, we saw on the course that there were some reasons to automate, and the ones that apply to this project is to increase the labor productivity, reduce labor costs, to mitigate the effects of labor shortages, to reduce or eliminate routine manual and clerical tasks, to improve worker safety, to improve product quality, to reduce manufacturing lead time, and to accomplish process that cannot be done manually. So for this, we need to do economic analysis and calculation of return on investment. Not only to say that it will be better, we need to prove that. So the economic justification for the project was based on the reduction of production costs by increasing the average output per hour. Also, the reduction in energy consumption per kilogram produced, also thanks to the increase in the output per hour, the reduced downtime, reduced cost of not quality, compliance with customer demand, and some other parameters that we use. Well, the expected profit from this process to the previous one is of 0.91 pesos, Mexican pesos, per kilogram produced. We have an annual demand of 2,300 tons per year. We could say that we have an annual profit from this process to the previous one of 2 million, around 2 million pesos. Here in this table we can see it better. Here our annual profit is this one in US dollar. We have an 12 years, we use 12 years to depreciate the machine. This is a profit before taxes, a 40% of taxes. We need to pay this amount of taxes. We have our annual profit after taxes, and this is our annual cash flow. So we calculate our payback, and it gives us 3 years and 7 months. Maybe it's not the most impressive payback, but I think it's a good one because this is a product that its demand is very constant. It's a line product, it's not temporary and anything. We have always have demand for this, for the sprinkles. And Gansito is a very strong product, so I think it's a good payback. And also the internal rate of return is 26.41, that I consider it a good one. Well, here's the images of the proposal. It is implemented already. Here is the installation. This is the machine for the feed of ingredients and the mixing with low cells. This is the mixer. Here is some ingredients container and it dosifier. Here there's another one, and here in the back another, and it goes all the way. This is up, and it goes down to the extruder goes here in the rotating breaker, and from here it goes the sprinkles coated through the cooling tray all the way to the end. Now at the end there's a dosifier. Out here is a better image of the handling of the ingredients. The handling of the ingredients do not depend on the manipulation of the operator, and all devices undergo foreign material control to ensure product safety. I think this is the most important advantage of this process, to ensure the product safety and also the quality assurance of repeatability from each batch to each batch. The system also includes display alerts to any deviation in the process, as well as safety devices at all stages of the process. Here I'm gonna show you. Oh, sorry. This is the end of the chocolate sprinkles project. I think I hope you enjoy it. I will show you, just because I think it's very interesting, another video from a new automatic line for decoration in praline that we are buying. I will show it to you. It really, I think it's nice. For example, here we can see there's an automated, this is the machine that decorates. We have the molds down here, As you can see, it is a robot, and it is decorating the mold. You can see, maybe you cannot see very well, but here are some white strips that are put on the mold. There are also this machine can have different kind of chocolate. Like you can see now it's black chocolate or dark chocolate. The molds are going and the robot is decorating. Then there's the molds are clean automatically. They are turned, yeah, like you can see, turn the other way out, and we have a clean molds. Then it goes to a depositing head, and it creates a shell of chocolate, and they go enter this machine which fills up this praline with another chocolate. Here's a shell, that shell, we can see it buried there. Then it goes to a tonnelet head where we can put nuts, pistachio, or everything we want to put inside the praline. Yeah, you can see here. For example, in this one we have 2 pistachio nuts and 1 hazelnut nut in each one. We can have two up to 3 fillings inside the machine. For example, you can see here white, nougat, and dark chocolate filling. Then it's a bottoming. At the end, we just put some more chocolate on top of the other one, and yes, that's all. I hope you enjoyed this presentation, and thank you very much for your attention and everything.